Thing coming up at the end of this month, Leap into Startup Weekend. Startup Weekend, if you haven't heard of it, it's an event where people basically try to form startups in a single weekend. And we're going to have a ticket sale launch party for the next one of these events. The Startup Weekend itself is happening April 27th to April 29th. But we're going to have a Leap into Startup Weekend ticket sale launch party on February 29th at 7 p.m. in the Baltimore's downtown. You actually do need a ticket for this one because the capacity is pretty limited. And we're going to have a keynote there, actually. Keynote, Uri from Kick Messenger. He was there from the start of it. And Kick Messenger, if you don't know, it's a messaging app for mobile phones. They sold 1 million apps in 15 days. So he's going to give a presentation and let us know what it was like with Kick Messenger from the beginning. The other big thing going on, the Bay Hackathon, run by the whole Open Hamilton, Open Data movement over there. They've done a lot of great things for our city, and they're working for free, March 2nd to March 4th. Check out openhamilton.ca for the details, and follow these guys, Open Hamilton, Joey, Brian, Nick, and Gavin, all the people that are doing great things. And the other thing, Tech Talk for Hamont, there's a camera there because they're trying to make some videos of our community and the people that are doing great things in our community, and to try to get that out to the world. So if they ask to interview about your demo or whatever it is you're doing, I'd sit down and talk with them so that way they can get that out to the world. And if you didn't get all that down, there's some great websites where you can find all this, like softwarehamilton.com and Innovation Factory and Raise the Hammer, where all these kind of events are typically listed. So just check out those if you're missing any of this. I'm getting a lot of people asking me like, okay, I want to get involved myself, like what can I do? And so just really quickly, the biggest thing you can do is just talk about things. Just talk to each other and connect each other. Because talking is really quick to do, it takes like a minute, and it helps people so much. So talk to people around you, get to know them, connect people if you can. If you see somebody that you feel like they could benefit from knowing somebody else, try to make that connection. Talk about these events that are going on. Apps for Health, you can tweet about that. You can talk to a friend to coming into the Bayfront Hackathon to increase the attendanship there. You can talk about the products you see here. You can tweet about them. You can use DemoCamp and Hamont to get the word out over Twitter about what's going on here. And if you can give advice to people about their own activities, their own startup. When people come up here and demo, if you think that they should know something or they should know about some certain competitor, you can tell them that. And so just do these cheap things that it doesn't take long to talk, but it can help people an awful lot. So that's just the simplest way to help. And if you've got more time and you want to organize some events, there's other ways to animate a community besides DemoCamp. There's Ignite talks, there's all kinds of technology talks. There's ways of growing the community with like Code Academy meetups and outreach and this kind of thing. So if you're into any of these kind of, if you want to actually organize something, we'll support you 100%. If you come out to Startup Drinks, we'll talk to you, we'll help you pull that off. So, all right, that's enough of the propaganda. Oh, and by the way, DemoCamp, the only reason why it's worked is because so many people help. There's like just a ridiculous amount of people that help whenever I'm having some kind of issue, or help to spread the word, or help to get sponsorship, and or make posters or make logos. So I've had a lot of help with this. All right, now the keynote. Ryan McGreal, he lives in Hamilton with his family. He's the editor of RaiseTheHammer.org. It's an urban issues online magazine. He's a big supporter of light rail in Hamilton as part of the Hamilton Light Rail Initiative. To work to get light rail transit in Hamilton. He's a programmer consultant, and you can check out all of his cool projects and tech blog posts on quandaryfactory.com. Cool. Just want to see if I can get my presentation set up.
Excellent. Okay, thank you. My name is Ryan McGreal. Thanks for that very kind introduction. And I'm here to talk about, going to make an argument that if you're building a web application, it might make a lot of sense to think about how to develop it in terms of building a platform and then building your application on the platform. Okay, so this I really got thinking in a very articulate way about this back in October. This is Steve Yagi, he's a Google engineer, and he posted what he thought was a private post to his coworkers on Google+, and accidentally posted it publicly to the world. And he said some really interesting things. Here we go. So he basically did a very impassioned rant about how Google wasn't a platform company. They do everything right in terms of how they operate, in terms of how they treat their employees, and things like that, in terms of their, don't be evil mantra. But they don't understand platforms. They provide products, but they don't provide services. He referred to the Google Plus API as a pathetic afterthought. I don't know if you've played around with it at all, but it's basically, he refers to it as the stalker API, because all you can do is do GET requests with it. So what his argument, and I guess my argument as well, is that it makes more sense to think about developing your software as a service. So a service is basically you expose your functionality via an API. The thing about a service is it's very kind of decomposed and it's very modular, so each business unit exposes its functionality via the API, and then they communicate with each other over the API as well. And what this does is, if you build it this way, all the functionality that you develop yourself in terms of kind of building up to having a product to launch, there's a lot of value in that. And if you build it as an API, then you can expose that publicly and you can share that value with the outside world. And if it's something that a lot of people find useful, it ends up becoming a platform. If people can build on your API and they can build their business on it, then that generates a lot of value and it puts you in a very enviable position. So I would argue that a good platform is powerful, reliable, accessible, and flexible. And reliability certainly is important. I'm sure you all remember the great Amazon blackout of 2011. I think when Reddit went down, they gained something like 10 million person-hours of productivity that day. So this guy's excited. Microsoft recognized that their business lives and dies on the API. They have created a platform, it's generated an awful lot of value for them, and what they recognize most is that what makes their platform value is not so much what they do with it, but what developers do with it. So when you have a platform, people can build applications on top of it. And the great thing about this is they are going to do things with your platform that even you wouldn't have thought to do with it. If you open things up, you know what a bunch of creative technical people are like. They're going to find ways to use your product or that you would never have thought of. And those kind of things generate additional value, and they make your platform more valuable. And it also increases the likelihood that somebody is going to come up with the so-called killer app for your platform. So a killer app is basically a platform, an application that makes your platform indispensable. There's a few examples throughout history. When the Apple II first came out, people kind of shrugged their shoulders, and then somebody wrote a spreadsheet program for it, and suddenly, you had to have this thing. It happened again on the IBM PC when Lotus 1-2-3 came out. Later it happened with, I guess, Microsoft Office on the Win32 platform. The last one I want to talk about a little bit more, the electrical grid. We kind of don't think about it anymore, and it's invisible, but it is abundantly a platform. The electric grid, when it was first built, it was rolled out strictly to power lights. The idea is we'll have electricity, and electricity runs lights. When houses in cities were first wired up, they didn't even have outlets. They didn't exist at first. You just had a wire that was hardwired to a light bulb, or to a light socket, and light bulb screwed into it. And it didn't take that long, though. After a few years, people recognized that with this electricity, you can actually build other things that run on electricity. So you had fans, irons, toasters. Somebody invented a vacuum. It was pretty heavy, but they got better later. And at first, these devices were actually built so that they would screw into the socket of the light bulb, which was not especially safe and a bit cumbersome. But after a few years, they kind of figured out that this was the direction the platform was moving, and so they invented outlets, which are a significant improvement in user interface. Again, you don't generally think about it that way because it's so invisible, but to this day, people are still inventing things that run on the electric grid that the people who invented electricity could never have conceived. That is a powerful, robust, long-lived platform. Here's another example. I just actually came across an article today, and it was a person who listed all of the applications that people have built on Git. Now, if anyone doesn't know what that is, it's a distributed version control system that was developed by Linus Torvalds, who's the guy who started Linux. And he basically invented it because none of the version control systems that existed up to that point were any good in his impression. So he developed his own and kind of put it out there in the manner that he does. And since then, people have used it as a database. They've used it as a backup and a file synchronization, almost like a Dropbox type thing. They've used it as a wiki, they've used it as a bug tracker, and people also use Git, and they'll deploy their apps directly through Git with post-commit hooks. So there's a lot of neat stuff you can do. And again, when Linus developed Git, he wasn't thinking about all this stuff. He just made it for his own use, but he put it out there, and other people found really interesting creative uses for it. So I guess what I'm trying to say is that when you create a platform and you make it available, you create a virtuous cycle, right? People want to use the platform because it provides functionality. They develop applications which other people want to use, and that in turn attracts more developers, which generates more value. You get kind of an upward cycle in the value that you're creating. A really important component of this, and it's really central to it, is this idea that you eat your own dog food. And what that means is you basically use the tools that you created. So if you build a platform, you build your application on that platform in the same way that somebody else would build their application on it. And that forces you to, first of all, be really conscious of what's good and what's not good. So when you're your own customer, you're going to make it better. It also kind of puts you in the customer's perspective, and it gives you an impression, if you like this and you don't like that, chances are other people might feel the same way. And finally, it demonstrates confidence in your offerings. There's a famous story actually from Microsoft, is when they developed NT, the developing team that made it actually developed NT on machines running NT. So you can imagine that was probably pretty painful early on, but they had a big incentive to get better fast. And the downside, of course, of dog fooding is if you take it too far, you can end up getting into a kind of not invented here syndrome, where you will only use stuff that you built, so you sort of have to be sensible about it. But Steve Beggy, who I mentioned earlier, his golden rule of platforms is you start with a platform and then you use it. So I mentioned platforms and I mentioned products, and what ends up happening is that you have sort of platforms here and products here, and there's no sharp line between them. The one kind of smears into the other at some point. So I'm going to overgeneralize a little bit here and just say that products tend to be more targeted, platforms are more broad, products are more differentiated, and platforms are kind of more generalized and integrated. A product, the idea is to get it to market, and a platform, the strategy is to kind of plan for the long term. With a product, you want to maximize profit, and with a platform, you want to maximize market share. You're capturing less from each sort of user or each component, but the idea is that you want to make it a lot bigger. So there are two different approaches. And again, products tend to smear into platforms when you kind of step back and look at it in different ways. There's certainly a lot of platform components where you build a platform and you can build your own modular products based on it and so on. And the other thing is that you can start with a product and realize at some point that it actually makes more sense as a platform, and then you kind of abstract the platform out of it. And it's a good idea to do that because in general, platforms I should say, tend to beat products in the long run. If you have a product and someone comes along with a platform that encompasses what you do, you're probably going to lose. We've seen this happen a lot. The market for word processors and calculators is pretty dismal these days because you can use a computer. We saw it happen with the cell phones. When BlackBerry came out, it was very much a product. It was a really impressive product, but the ability to build on it was really constrained. And then Apple came out with the iPhone, and they had the app marketplace, which provided a lot more functionality for third parties to build applications. They came up with some good tooling, and suddenly you had all these fantastic apps, and you had all this additional value for the product that people out in the community are making. And then Android did it to Apple by being even more open, I would argue. You saw it, Amazon did it to bookstores, Facebook, it was around before Google, but one of the reasons Google's having a hard time with Google Plus breaking into that is that it's not extensible in the way that the Facebook API is. A lot of Facebook's value comes from what, Farmville and things that other people are building on their platform. And I would also argue that more open tends to win over more closed. There's, kind of analogous argument here, but one of the reasons why, every computer in the 80s was running DOS was that Microsoft figured out that if you had very cheap licensing and if you had a permissive license where it was non-exclusive, if you can get this operating system onto as many computers as possible, you're going to win by default. There were some arguably better operating systems out there that didn't win because they were more closed and they wanted more control. You saw Win32 do the same thing to Mac OS, and I remember a friend of mine had an Amiga, and we just thought it was the coolest thing on earth, but it was a relatively closed platform. It was a hardware, software combined. You couldn't license it, and so they ended up losing. You saw it happen with the World Wide Web, which was the ultimate open, non-proprietary platform, and it beat all of the digital networks that existed throughout the 70s and 80s. CompuServe, AOL, the Source, Prodigy, Minitel, they're all gone, or they've been rolled into the internet. And we saw it happen again, like I said, Android being more open than iOS. They've got a lot more market share. iOS has a higher profit margin, so there's kind of different ways of looking at it. Now the other thing is, I mentioned that you can, when you build a platform, somebody can build a killer app. You can actually build your own killer app as well. And we see that happen, again, Microsoft does it with MS Office. The Facebook platform's killer app is Facebook itself. Same thing, Amazon platform's killer app is Amazon. Now I'm going to talk some more about Amazon just because Steve Egge used to work at Amazon and then he moved to Google, and his essay, his rant, compared the two, and it kind of got me looking a lot more into it. It just provided a really, really exciting case study for what I'm talking about. Okay, yeah, so I kind of talked about this a little bit. One of the things is when you're building a product and you decide later that really should have been a platform, it's really painful to try and extract, or abstract a platform out of this product if you build something that's more monolithic. If you're building something that's going to be a web application, build a platform first. You'll save yourself enormous amounts of aggravation later, and if your company has gotten to any size, you'll save yourself the struggle of trying to change an entrenched culture as well. Now, I mentioned electricity as kind of a platform that nobody thought of as a platform until people started building things on it. Amazon is another thing. This was a quote from Steve Egge. You wouldn't really think that an online bookstore needs to be an extensible programmable platform, would you? And yet, in 2002, that's exactly what this guy decided. This is Steve Bezos, the CEO of Amazon, and he went in and sent a message to the entire company, and he said, look, from now on, you're only going to build web services. Every single department in this company, from payroll to server provisioning to whatever, you are only going to expose your functionality via web services, and if you need something from somebody else, you're going to consume their web services. And being Bezos, he made it happen. It took him about 4 years to make this transition. It cost millions and millions of dollars. But what you find now is that Amazon, since 2006, has been rolling out all kinds of different web services. And you have all kinds of other businesses now that are building their products on top of the Amazon Web Services platform. And what's interesting is some of these businesses are in turn platforms, and you have other businesses that are actually building tools on top of businesses that are built on top of AWS. So you can argue that it's platforms all the way down. The other important thing, of course, is that it's actually making money. They launched in 2006. Last year, they'd made around $750 million. This year, they're on track to make about $1 billion, and it looks like they'll make around $2.5 billion by 2015. Now, these numbers aren't exact because Amazon doesn't separate out how much money they make specifically from web services, but these are sort of the best estimates that analysts have come up with. So there's real money to be made there. And this is sort of the conclusion for what I'm saying about this, is that platforms, they express value. When you create a product, you create all kinds of really, really clever functionality. And if you build it as a platform, sometimes the things that you thought was really important is actually not that big a deal, and something that you build as kind of a peripheral or supportive or supplementary technology ends up actually being a lot more exciting. And if you launch and you go to market, what you may find is that what you actually have created that's valuable is not what you thought. And if you have created and designed it as a platform, it allows you to do that kind of a pivot, and figure out what your market is and go after it more aggressively. So I'm going to talk just a little bit about web services. This part was a lot longer, but I cut it down because it's a bit on the technical side. But I have sort of written a lot more detailed, and there's a link at the end if you want to kind of go and find out some more. But an API, of course, an application programming interface, is an interface that allows a program to expose its functionality to the outside world. And a web API is a program that exposes its functionality over the web. So there's basically two, okay, I'll get there. Yeah, so there's, when you're building your platform, these are the kinds of considerations that you want when you're thinking about the users. It needs to be usable. needs to be useful, it needs to be explorable, right? So people can find out what it is. It actually does something useful when they get to it, and they can figure out how to make it work. It's got to be accessible, right? So it can't be using some narrow proprietary technology that you have to be running .NET version 3.5 or else you can't get it to work. And it's got to be reliable as well, of course. And as a developer, the considerations you should kind of have in mind for yourself are it should be clean and consistent organization of your functionality. It should separate kind of the different conceptual layers. It should be flexible enough to allow you to adjust and change the application that you build on top of it without too much work. And finally, as a developer, you're also a user. So it should be, let me get that little pointer out of the way. So you will benefit from all the same considerations that your users will benefit from if you're keeping that in mind. So the two kind of broad principles that I would suggest is design for adoption. So when you're asking a question, of how should I do this, think what will make this easier for people to use? What will make it easier for me to use? And then finally, design for maintainability. What will make it easier for me to know what the hell I was doing 6 months later when I have to go back and look at this again? So there's two types broadly speaking, two types of web API. There are remote procedure calls, and there are HTTP web services. And I'm going to get into a bit more detail about both. So RPCs, essentially, the idea is that you've got a client and a server, and the client will consume the server's procedures in a way that makes it seem like they're actually calling local method calls as opposed to calling them over networks. So you're abstracting away the fact that it's remote, and it's behaving like it's something local. Again, it uses HTTP. HTTP is just about everything runs over HTTP these days, but it just uses it as a dumb transfer protocol. All of the important stuff, authentication and the objects and the data and the methods, anything that the server needs to know gets put inside an envelope and it gets sent across as part of the request body. And then finally, there's a kind of an arbitrariness to it because different RPCs work in different ways, and none of them work the way HTTP works. Here's a few examples, Corba, XML RPC, MS RPC, and then SOAP I'm going to talk a bit more about because a lot of these different RPC methods came up in the early days of the internet when the web hadn't really entirely taken over yet. And so SOAP emerged as a kind of a standard. It was an attempt to standardize XML RPC, and basically, you've got a single endpoint URL. Every request made against it is made as a post request, and it produces a web services description list, which the client can consume that, and they can kind of figure out what methods are available and what parameters they require, and things like that. So the benefit of SOAP, especially over where they were previously, is that you've got essentially push-button tooling. Like there's a lot of pretty well-developed tools where you build an application in Java, you hit a button, and now you've got a web service for it. So that's kind of nice. The client is able to theoretically introspect the functionality by consuming the WSDL, and it sort of, again, like an RPC, it abstracts away the fact that you're doing this over a network. But of course, as we know, all abstractions are leaky. And SOAP never really works as well in practice as you'd like to work in principle. Quite often you don't have the interoperability you want. I've had numerous situations where I've been trying to consume a SOAP web service and it just doesn't work. And you end up having to build XML templates manually, and it's all the stuff that gets abstracted away ends up just being stuff that makes it harder for you to figure out what's going on when it doesn't work. And the biggest problem with SOAP is almost more of a philosophical problem, but it runs on HTTP, but it doesn't use HTTP. So you've got a technology that's designed for requesting resources over a network, and we're not using it. So I'm going to propose, and this is where it gets a bit more opinionated, that it makes more sense if you're making a web service to use the technology that runs the web. And so that's HTTP. So again, it's a client-server model again. The client makes a request against the server, it requests a resource, and the server responds with it. And it's really very, very simple. It's stateless, so all the information that the server needs to respond to the request is contained in the request itself. And it's also cacheable. So basically, there's a sort of a formal term for this called representational state transfer, or REST. And this was formalized in 2000 by Roy Fielding, who was actually one of the architects of HTTP. And he wrote a PhD thesis, which almost nobody understood. And people have been misunderstanding him ever since. He basically came up with a protocol for a web-based service that works the same way HTTP does. Now, Fielding will argue that it's not dependent on HTTP and that it actually could run over anything, but realistically, it always runs over HTTP, so I think it's more confusing than clarifying to try and draw that distinction. Like I said, it's widely misunderstood. There's a lot of services out there that say that they're REST, and you look at them and they're actually not. So basically there's, and again, I'm kind of generalizing a bit, but there's 4 basic elements to an HTTP web service. You have resources, methods, and you have status codes in the response, and hyperlinks. So I'll talk a bit more about these 4 things. The important thing to remember about a resource is that it's an object. It's a thing, it's a noun. It's not an action. So every URL, every resource has a single URL, and every URL is an object, not an action. So this idea of having a URL called create user, that's not sort of the right way to do it. It's better to have a URL called user and then use the right method on it. So that's the next part. When you want to create a user, you do a post request. So you have different HTTP methods. If you want to retrieve a user, you do a get. If you want to update a user, you do a put. And if you want to delete a user, you do a delete. And again, if you've used the internet, when you fill out a form and hit the button, your browser is doing a post request to the server, because let's say you're filling out a comment or whatever it is. The idea is a post actually causes the server to create something, whereas a get, which is what you normally do when you type an address in your address bar, you're just retrieving something. So status codes are important. This is how the server tells you what it thought of your request. This is an HTTP 401, the poor cat's not allowed inside. So I won't get into too much detail, but you're probably familiar with a 200 OK. If you make a request and the server is OK with it, it gives you the response and it says it's OK. A 404, which you've probably seen, that's the server telling you that the resource you've asked for is not found. 500 internal server error is usually a bad sign. And the other thing that's critical to an HTTP web service is that it runs on hyperlinks. Every resource in your service has a unique URL, and when you do a request against a URL, the response includes any other URLs that are links to other things that you need. So when you go to the root, if you go to the home page of a website, for example, what does it have? It has links to all the different sections on the website. You click on, let's say you want to read articles, you click on articles, now you have a list of all the articles. That's how an HTTP web service works as well. You hit the root URL of the API, and it gives you links to all of the different API resources. Let's say you have one called users. So then you go click on users, and now you have links to all of the users, so you can do a GET request on each user. And if you want to create a user, you do a POST request against users, and it generates a new user, and it'll respond with that new user's URL. So here's just a basic example. You do a GET against, the slash is just sort of the root, and it'll return, it'll tell you that it has users. So then you do a search against users, and it'll tell you there's a user called Ryan. So then you click on that, and you find out all about me. So again, the idea of this is that you're not going to reinvent the wheel. HTTP is already there. It's there whether you use it or not. So don't rebuild all the things HTTP does on top of HTTP. It's kind of a waste of time, and it's harder for people to understand what you're doing. And the other nice thing about HTTP is that, again, because it's entirely driven by hyperlinks, it's discoverable. You can go to the root of a web service that is designed this way, and you can find out everything from there that the thing can do. So that's kind of nice. You don't have to read a lot of documentation. For a developer, it makes things a lot easier for them to figure out what they can do on your platform. So this, I don't know how well you can see this, but this is kind of just running through. And again, I've mentioned this a little bit, but you do a GET request against the root, and it'll tell you that there's a resource called users. Do a GET request against that, and it'll give you a list of users. If you want to create a new one, you do a POST request against it, and then it returns and says, okay, we've got a new user, 1337. So then you can get that, you get the details for it. If you want to update that because some of the information is wrong, you do a PUT request, and then if you want to get rid of them, you do a delete request. And then if you do a search for it again, you get a 404 message because user has been deleted. And the one last thing, and this is also a bit opinionated, but I'm going to say, unless you have a really good reason for using XML or something else, just use JSON. This is a JavaScript object notation. It basically just allows you to, to create kind of an arbitrary object. You know, you can have like a hash table, like a key value kind of thing. You can have a list, you can have different data types, and you can nest it arbitrarily. So it's generally flexible enough for any kind of data you want to transfer. Again, unless you have a really specific business reason. The nice thing about JSON is that it's really easy to read. Any language and any platform on the world can consume it very easily, so you don't have to worry about interoperability and all those kind of things. It pretty much just works. So I guess that might not be that easy to see, but here's just an example of what a JSON object might look like. So you get a list of resources. Each resource has a name, a description, and the URL for that, so you can find out how to get to it. So again, the benefits is that it's navigable the way a website is, and we all know how that works. The URLs are better if they're clean, they're sane, they're descriptive, they make sense, they're stable. The URLs refer to resources in a kind of predictable way. And it uses what HTTP already gives us. You're not kind of having to manually build it on top. The last two items here, developers understand HTTP and the tools understand HTTP. I've got an asterisk there because they deserve a bit more detail. So the problem is with those two things is that they're true, but they're kind of not true as well. People understand HTTP, but most people don't understand it that well. And so what you end up doing is if you create like a REST or an HTTP web service, some people are going to cotton onto it right away, and some people are going to kind of struggle a little bit. It doesn't have the kind of push-button tooling that XML or that SOAP has. At the same time, when you build it, you know it's going to work. So there's that. And then the default client HTTP libraries in a lot of programming languages tend to be kind of crippled. They work the same way browsers do, right? So you can do a GET, you can do a POST, but browsers generally can't do a PUT or a delete request. And kind of default HTTP libraries for languages, a lot of them can't either. The good news is that it is getting better. More people are actually coming to understand 22 years after it was invented how HTTP works, which is kind of nice. And a lot of the newer web frameworks, they run like this now. Like if you look at Rails, or Merb, or Web.py or Django, even a lot of the new PHP frameworks, you can actually, they internally handle HTTP like this. So the service is looking for when a request comes in, this is the URL, this is the method. Okay, so now how am I going to route this request? And so internally, tools are starting to think like this, so it makes sense to start thinking like this as well. And that's basically it. If you want to read some more about it, I've got a link to the summary here, or this presentation is posted on the web, and then I've kind of written a more detailed summary with a bit more technical stuff below it. There's a classification of HTTP-based APIs that kind of starts with like RPC and becomes more and more RESTful as you go down. And then finally, OWASP, the Open Web Standards Project, has a security cheat sheet for how to make a secure RESTful website. I don't want to talk about that because I'm not an expert on it, but it's certainly a good resource. That's about it, really. That's all I have.